Hello friends, welcome to our first training module, Basics of Electricity. The electric current. Electric current refers to the flow of charges. Every object on this planet is made up of atoms. The atoms are made up of electrons, protons and neutrons. The central part, the nucleus of the atom, contains protons which are positively charged and neutrons which are neutral. Electrons, the negatively charged particles, orbit around the nucleus. These electrons are responsible for the electric current. The electrons move in materials from atom to produce current. The battery is a device that carries out electrochemical reaction within itself. This reaction creates a force that makes the electrons move from the negative end to the positive end of the battery. This force is referred as potential and is responsible for the electric current. Some insight on the battery. A battery has two metallic plates. One plate with excess electrons due to the electrochemical reaction. The two plates, however, are not connected with each other inside the battery. The plate with excess electrons is the negative end of the battery. The other plate is the positive end. Connecting the negative and the positive end of the battery externally using a conductor will provide a path for the excess electrons to flow. Flow of current, always a confusing topic. The conventional flow of current has always been stated as flow from the positive to the negative. It was Benjamin Franklin who established this conventional flow of current. But it was later discovered that electron flow is actually from the negative to the positive end. However, it was too late and confusing to change the standard which was being used. Today, both the conventional current and the electron flow are used by the industry. You may note that it makes no difference which way the current is flowing. The direction of the current flow does not affect what the current does. You may choose any standard as per your convenience, but always remember that the conventional flow of current and the electron flow are opposite to each other. A short circuit. Connecting the two ends of a battery by a conductor results in a short circuit. The short circuit heats up the conductor and may burn the material. A load, like a light bulb, can be connected to the battery. The load uses up the energy due to which the metallic wire does not heat or burn. Measuring voltage. Voltage is always measured in parallel. Keep your voltmeter or multimeter leads across the point where you want to measure the voltage. To measure voltage at a point, keep one lead at the point and the other lead at zero or reference voltage. Measuring current. To measure the current, you will have to break your circuit and connect the ammeter in series as shown in the diagram. Let us look at the Ohm's law. The potential difference or the voltage in a battery makes the charges flow. The current is defined as the rate of flow of charges. This rate depends on the force or the potential. Hence, we can safely state that the voltage or the potential difference is directly proportional to the current. However, the current drawn also depends on the conductor material. The conductor or the load in the circuit offers resistance to the current flowing. Hence, the Ohm's law can be stated as voltage is equal to current into resistance of the conductor. You can see the circuit. The current drawn by the circuit depends on the battery voltage and the resistance of the circuit. The metallic wire and the load connected both are responsible for the resistance in the circuit. Here is a small activity for you. You can buy a 1.5 volt AA battery, a few LEDs, some wires and a multimeter. Try connecting the circuit as shown on previous pages and try to measure the current and voltage. Also try to connect more than one LEDs in series and measure the voltage across each LED. What do you observe? Do write to us.